Hey there, I'm Mark, and today we're going to go over scientific notation and rounding to one decimal. So let's start with a simple one. We're going to convert from scientific notation to a regular number. So let's take 2.9 times 10 to the third. So what is 10 to the third? 10 to the third is 1,000, and whatever the exponent is, that's going to represent how many zeros you have in there with positive exponents. We're getting to negative exponents soon. So we got 3 zeros in there. That means we're going to move the decimal point over 3 times, and so we take 2.9 and we're going to move it 1, 2, 3 places. And so we erase that, and we have 2,900. So pretty simple. All you're doing is moving the decimal points over. Let's do another positive one. We're going to do a positive 3.65 Let's do it the other way. 3.65 0 0 0 0 0 0 0. Alright, I want you to round this to one significant digit. So what that means is we're going to take that first number and we're going to round that off, and then we're going to count up the zeros. So if we were going to round it just to this digit, to the nearest billionth, because this is 3,650,000,000. So since this is a 5 or greater, since this second digit is a 5 or greater, we're going to round up. If it was 4, 3, 2, or 1, we would round it to 3, but since it's 5 or greater, we're going to round this to 4. And so we have 4 times 10 to the something power. Or actually, we're just going to write it as is. 4 billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's 4 billion. And so we're going to pretend we just have a 4, and there's a decimal after it. 4.000000000, and so we want to write it in the form of 4 times 10 to the something power. And so we just count up how many times we're moving the decimal over. So we're moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, and so this would round off to 4 times 10 to the 9th power. Alright, let's do 2 more positive numbers. So, which number is bigger? 4 times 10 to the 9th, or 7 or 800 million? Which number is bigger? So it's hard to compare these like as is, so let's convert this to scientific notation. So we're going to take the first digit, we're going to have 8 point, and then we have 1, 2, 3, 4, 5, 6, 7, 8 zeros afterwards. 4, 5, 6, 7, 8. I'm going to move it over 8 times to get the number we want. That would be our new decimal. And so that would be 8 times 10 to the 8th power. And so which number is bigger, 4 times 10 to the 9th or 8 times 10 to the 8th? See this first number, it doesn't really matter. When you're comparing which one's bigger, you compare these first. You compare the exponents, because those are way more powerful than the leading numbers. And so 4 times 10 to the 9th power is definitely going to be bigger than 8 times 10 to the 8th power. And let's say they ask how many times bigger is it. So the way we figure that out is we take the bigger number, divide it by the smaller number. So we have 4 times 10 to the 9th power over 8 times 10 to the 8th power. And so 10 to the 9th power means we have 10 tens being multiplied by each other. Or 9 tens, I mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 8 times 8 tens. 1, 2, 3, 4, 5, 6, 7, 8. We have these all multiplied by each other. So since these are all multiplied by each other, and these are all multiplied by each other, and there's no pluses or minuses, and it's division in the middle, we can eliminate each one individually. So what's 10 divided by 10? It's 1. And so we could just cross these out because those will become 1. It'll be 4 times 1 times 10, 10, 10, 10, 10. And we can cross out all the ones that even up. We can cross out this one, this one, this one, this one. And we're left with 1 10 on top. And so we're left with 4 times a bunch of 1's, which we don't have to write. 1 times 1 times 1 is 1. Times 10 over 8. And so if we want to know how many times bigger, 4 times 10 is 40. 40 divided by 8 is 5. So it's 5 times bigger. Alright, let's do some negative ones. Let's say we want to convert 0.0000003652. We want to convert this to scientific notation with only one decimal place. So we only want to use one significant digit. And so what we're going to do is we're going to look at that second number, the number right after the first non-zero number. And if it's 5 or above, we're going to round this up. If it's 4 or below, we're going to round it down. And so since it's a 6, that's greater than 5. This is equal to about how many zeros we have? 1, 2, 3, 4, 5, 6, 7. 7 zeros. 1, 2, 3, 4, 5, 6, 7. And we're going to round it to a 4. Alright, where do we write that? 0.0, 3, 4, 5, 6, 7, 4. Okay, so the way I like to do this is we need to see how many places we're going to move this decimal point over. So we're going to write 4, and then we're going to count how many spots do we need to move it to get the decimal in the right spot. We're going to move it 1, 2, 3, 4, 5, 6, 7, 8. So we're going to move it 8 spots, because to turn 4 into 0.00000004, we're going to have to move it 8 spots over. And so the way we do that in scientific notation, since this is 8 spots, we're going to do 4 times 10 to the negative 8. So if you want to make the number, if it's below 1, it's going to be a negative number. If it's above 1, it's going to be a positive number. So we got 4 times 10 to the negative 8, and that's how you convert from one spot. That's how you convert from a decimal number to a scientific notation number. Let's say you have 4.2 times 10 to the minus 4th. How do we convert that to a decimal number? So we have 4.2 And this means we're going to move it over 4 times. We're going to move the decimal over 4 times. So let's write some leading zeros. 0.2. We're going to move it 4 times. So 1, 2, 3, and 4. And so this is going to be equal to 0.00042. Okay. Now let's do the same. We're going to compare and contrast. Okay, which number is smaller? 8 times 10 to the negative 8, or 6 times, let me go to 4. 4 times 10 to the negative 6. So we want to know which one is smaller. What's the smallest number? You could just ignore, since the exponents are not the same, we could just ignore the first numbers. We could ignore the 8, we could ignore the 4. I know your instinct is to say this one is bigger. We got a bigger 8, we got a bigger 8, but it is not. It's negative. So the bigger number is actually the 4 times 10 to the 6, and this is a smaller number. And now, a lot of times you'll be asked, how many times bigger is the bigger number than the smaller number? So we're going to do the same thing we did before. We're going to divide this number by this number. So we got 4 times 10 to the negative 6 divided by 8 times 10 to the negative 8. If you saw in my last lesson, whenever we have a negative exponent and we want to make it a positive exponent, we just switch it from the top of the fraction sign to the bottom of the fraction sign. So we could just switch both of these and then make our exponents positive. So this is equal to 8 times 10 to the 8th divided by 4 times 10 to the 6th. And now we do it exactly the way we did it before. But instead of just writing out all those tens, we could just subtract. We got 8 tens on the top, we got 6 tens on the bottom. So that means these 6 tens will cancel out 6 of these tens, and it'll cancel out itself, and we'll be left with 2 tens. And so that will be equal to 800. 8 times 10 times 10 is 800 divided by 4. And then 800 divided by 4. It's a pretty simple problem. Got 2. 2 times 4 is 8. 0, 0, 0, 0, 0, 0, 0, 0. So it's 200 times greater. And that's how you do negative exponents. If you're interested in tutoring with me, I have some time slots available this semester. You can reach me at markehannah@gmail.com. Alright, I hope that helped. See you later.